Hi there everybody, it's the whole universe, hope of this fine Irishman who brings value human experience, and today we're gonna communicate with you about neural networks. What are they? They are models of our biological neural networks that we have inside of our brain, basal ganglia, Wernicke's area, Broca's area, and other things that we have inside of our mind, synapses, axons, and also nuclei, and things of this nature. And actually we have the artificial neural networks. They are the model of our biological neural networks, and we have the perception of different types of visual data, also audio data, olfactory sometimes through the smelling, also haptics, and also some of the pressure we can detect to and kind of identify us. And this is actually the inputs we have. In most cases it is only pictures. Yes, pictures we can see, OpenCV things, and also some of the images, okay? And also we can see also and listen to the music and things of this nature. Okay, we have specific vectors of data. Actually in the computer it is our digitalized data that we have through the perception. Okay, we have inputs, we have outputs. Outputs, what they are? Outputs are the specific forecasts, predicts, guesses, and also things that maybe this will be, maybe that will be, maybe this will be with the percentage of probability of 0.86. Yes, 0.86 or maybe 0.99. Oh, it's amazingly nice, kind of 99% that it is happening. Yes, and it is the same as for the annotation of images. I imagine that you have the photo, you have your phone. Yes, you are kind of you are moving, and actually you see the person, you kind of show it to the camera, then camera detects it, and then we have the picture, and then we have the annotation for it inside of the box. And we have something like, it's a hand, yes, it is a hand, and it is a hand, yes, really, or it is a finger, or maybe it is the phalanges, or I don't know what's the name of it in English, by the way, and maybe it is the specific part of the finger, yes, that we've seen it. Okay, it is our inputs we have, and also we have outputs. Outputs, it is what I already said, it is specific guesses. Maybe it is, maybe not, and we have the confidence level. Confidence level means that confidence thing that we can see, we can say that it is, yeah, so a confidence threshold, we can name it. For example, if 95% plus, then yes. If 0.55, then yes, maybe, yes, or maybe 0.75, it is more yes than no, yes, and kind of this type of thing. And we have this, and we have the prediction for something, maybe prediction for the classes, maybe prediction for this dot, it will datenpunkte, this data point will be belonging to this cluster or something else. Actually, neural networks could be used in different tasks, and majorly in classification task, kind of what it is. It is the class number 1 or class number 2, binary classification, or ternary classification, class number 1, class number 2, class number 3, or multi-class classification. It is n number of classes we have, and actually we can say 1, 2, 3, or n, yes, or m, or l, or k, or other letter that you can put here, we can detect. Okay, and we have different types of neural networks. We have RNN, CNN, DNN, HN, KN, P, LSTM, AE, VAE, SAE, DAE, GAE, GAN, JAN, GNN, DFF, FF, DBM, BM, RBM, NTM, ESN, ELM, GRU, and also MLP and others, and also different types of inside of it. So we have also YOLO, YOLO, version 4, version 5, version 6, 7, 8, and also tiny, and also other things. Actually, it is different types of convolutional neural networks we have, and actually all this abbreviations that I said already: recurrent neural networks, deep neural networks, convolutional neural networks, deconvolutional neural networks, autoencoder, variational autoencoder. It is all about different types of neural networks. What we should know mainly about neural networks: how do they work? We have input layer, we have output layer, we have latent layer here it is. Yes, for guys who maybe in the beginning, oh Jesus Christ, Igor, you said only inputs and outputs, okay, oh, but where is latent? latent layers. Yes, we have hidden layers, and they are here. Yes, kind of. They could be the majority of them. Maybe it will be only 3 layers or 4 layers, or maybe it could be 60 layers, or maybe 200 layers, or it could be only 2-3 hidden layers. Actually, we have inputs, we have outputs. Hidden layers, it is the specific kind of steps that we see something. For example, we can detect some parts, then we can guess in the next generation, then we can think about in the next generation, next, and then will be output that yes, it is this one, or that one, or this and this at the same time. And actually, it is hidden layers. They are kind of helping to us to understand the context. Maybe, for example, if we say the word apple, yes, you can guess that it is maybe apple as a phone, or maybe apple as a fruit, or maybe apple it is green apple, or maybe or blue. Yes, for example, it may be sweets called apple, or maybe it is the specific label that is written as an apple, as a text. Yes, NLP, NLU, NLG, natural language processing, natural language generation, natural language understanding. Yes, and things of this nature. And actually, we have the inputs, and with the context we can understand what it is, what's the output will be, what will be the final guess, final predict, final forecast, and etc. And okay, we have also different types of things called metrics, or actually it is activation functions. Guys, it is activation functions, it is called officially. Activation functions, it is the specific functions, for example, ReLU or leaky ReLU, or maybe it could be a sigmoid function, or softmax, or etc., or this type of thing. Yes, and we have the activation functions ReLU, it is max parenthesis 0x, and also we have, or x max 0x, no, one moment, 0x. Yes, 0x, yes, it is a ReLU rectified unit, yes, leaky rectified unit is 0.x, then comma x, then could be also it could be softmax, it is the specific function of exponential divided by the sum of exponentials. Also we have this specific function, sigmoid function, it is this one, and we have the equation of 1 over 1 plus e to the power of minus x. And what is it actually? It is the specific activation functions that help to us understand it is right or it is wrong. In the hidden layers, we have a lot of these functions. Actually, we can have the composition of these functions, kind of hard, complex functions that are composition. Yes, one function inside of it, one more functional as a noun. Yes, functional as a noun in rational language is the same thing. Okay, and we have kind of composition of them, and also we have the activation functions that help to us to learn more about something. Kind of, if yes, okay, kind of more weight, more kind of myelin shell will be created. Myelin shell is a specific thing that is covering our inside of our mind. We have the specific axons, and they are covering our axons. That and connection will be stronger between the different types of nuclei, nerve nuclei, and etc. Okay, and also we have activation functions, yes, as I said before, and also we have weights between the things. For example, we have one input, we have hidden layer, one more hidden layer, and one more output, and we have here roads. Yes, roads, they are kind of like in weighted graph here, and we have kind of the weight of this. The bigger the weight, the more probability that we will go this road. For example, you are going from home to the place where you need to go. You can go through this line, or that line, or this line, and you kind of intuitively at least understand that from this to that will be the shortest. This will be longer, this will be longer too, and it means that this will be the most appropriate, and means that 90% that you will go this way, not that, not this, or even 98% 0.1% that you will go there. It means 0.98 that go through this and everything will be fine. So it is the weight, specific weight that you have, and activation function could help to us to increase this weight that need to go there. If it was already safe place, then okay, yes, go again, okay, kind of this way and that way. And actually we have different types of neural networks, and it is actually a mathematical model how to understand our artificial neural networks, how to understand them, künstliche neuronale Netze, how to understand them. It is actually the specific decision tree that is super mega complex. We have decision trees, we have random forests and other things. Actually it is the classifiers in classification machine learning task. But actually we can think about artificial neural networks as a decision tree. Actually we have the inputs, we have outputs, and we are going from this to this. It is kind of complex, more functions. It is function of the function. Actually it is the composition of functions. If we can think about neural networks, it is the composition of the functions that we have inputs, attributes, input attributes, and we have output attributes that we will have. And also we have some operations: multiplication, addition, subtraction, division, integration, differentiation, exponentiation, logarithmization, convergence, divergence, and things of this nature. Yes, and inside of it, and different types of mean, median, mode, numbers, and things of this nature. It is we can input inside of it. So thank you a lot for watching this video. Hope you enjoyed it. Leave in the comment section below what do you think about it and what do you want to see in the next video, and we will create this video with you together. And let me know in the comment section below where do you study, what do you study, and because different types of people are watching my videos, and they could be from school or from university, or they're working somewhere. Okay, thank you a lot for watching. See you next time, and improve self daily. You're a nice guy, girl. Bye.